Alright, it's John here, and we are back working on Project Euler, and we are going to now do problem 11, largest part in a grid. And basically we're going to take this grid and look at all the adjacent numbers, so 4 adjacent numbers, diagonal, left, right, down, up, whatever, and find the biggest product of 4 adjacent numbers. So let's get started. We're going to copy and paste the string in here. So I'm going to say def raw and have a string. Alright, and let us evaluate that in the REPL. So there we go, we have this big string. Alright, so the next thing we want to do is we want to split that up, so we'll do Clojure string slash split, and it looks like there's a split lines function that we can use. So let's do that. Okay, so let's just call this our lines. Okay, so now we have lines. So we're going to take each line and we want to break it up into individual numbers. So we want to basically take lines and we want to turn it into, we'll call it num strings. And we'll do Clojure dot string dot split, and we are going to take in, what did it say here? Split. We're going to take a character sequence and then a pattern. So this character sequence is the input and the pattern is the regular expression space. Okay, but we want to map this function that we have now made across the lines. Alright. Okay, so we evaluate that. Let's see what it looks like. In the REPL, numsters. Okay, so now we have a list of vectors of the individual numbers as strings. Okay, so now what we need to do is we need to map a function that turns those strings into actual numbers. So let's see, we are going to map across all the values in the list, and then so if we, let's see, if we do map identity here, then we get the same thing back. So for each one of these vectors we want to map another function inside of there. So our function here, let's try that, make sure we're still good. Yeah, we're still good. Okay, so now this in here is going to be the actual string. So we want to map we want to change the string into an integer, and there is the read string function. So we can call the read string function on whatever comes in here. Okay, nested function literals. Alright, we need to make this differently. So we'll make a function that takes in a number. Oh, yeah, I'll call it number as a string, and we are going to read the string in here. Alright, let's give that a shot. We made the function, and then we want to call it. Sorry, get the parentheses in the right place. And things are just getting worse and worse. Alright, sorry about that. We're getting lost in these nested parentheses. Okay. So now it looks like we finally got there. Okay, we have an invalid number. So okay, so what does that say? It says 08 is an invalid number, which means that it's taking that string. It sees a leading 0 and it says that's an octal number. A little aside rant about octal numbers. It's 2015 and we don't need octal numbers anymore, so nobody should ever interpret strings with a leading 0 as an octal number, because who uses an octal number? Like, if you try to ping a site and somebody has listed their IP address with a 0 inside one of the octets, then Windows would treat that as an octal number and give you something you don't expect at all. So everybody out there, stop it with the octal numbers. Alright. So we need to change that to integer slash parse int. We give it our string, and then because that would probably also treat it as an octal number with the leading 0, we'll go ahead and pass in a radius of 10 just to be sure. So let's try this one. Okay, look at that. So we have the list of numbers and a list of numbers. Okay, that looks like exactly what we want. So we are going to be doing lookups based on indexes as we go through here. So what we want to do is, for each of those, we want to put them into a vector. Let's see where we go wrong here. So into a vector. Okay, now the outside one is a vector, and then in here we want to map this into vector. Try that. Okay, good. So now we have vectors of vectors, so we can do things with indexes and look things up efficiently. Alright, so we will define this as our, let's call it our input. Okay, and then as we try to solve this, we're going to be walking around this map, applying offsets, and I really don't want to think about boundary conditions. So I just what I want to do is pad this whole map with ones, because we're going to do multiplying. So ones are basically harmless in multiplying. So let's do a for for x is in the range through 26. Because we're going to be using 4, we're going to pad 3 extra 1s onto each side of this thing. So we'll do for x range 26, and we will do for y in the range 26. And then what we'll do, we're going to build up a new map that's padded. So what we're going to say is if we're within the bounds, then we're going to put in something from the bounds. Otherwise, we're just going to put a 1. Okay, so our else is 1 and if, and so the if is going to be, let's make the function in bounds x and y. And for right now, we'll just always return false. The inbounds, if inbounds x, y, then we are going to grab it from the raw map. So what we want to do is we want to say get in, because we have our nested vector. So we're going to say get in raw, and then we're going to have minus x3 and minus y3. Okay, because we're going to have these extra offsets when we're building this thing up. Alright, so let's evaluate that. Symbol inbounds, we need to create our function, evaluate this. Okay, and so now it gives us nothing but 1s as we expect. And we want to make that also be a vector, so we're going to do into vector here. And then the outer one should be a vector as well. So let's try that. Okay, so now we have vectors of vectors all with 1. And so now on the inbounds, what we want to say is less than, is x less than 20, let's see, is it less than 23, and is it greater than 2? Is x greater than 2? And same thing, y is less than 23, and y is greater than 2. Alright, let's try that out. We can evaluate that function. Let's make our new map. Oh, we said I put raw here. What I meant was input. Sorry. Let's try that. What are we doing wrong here? 1, 1, 1. Get in input. Input. And I've got this backwards now that I look at it, because the y is the first, and basically our first set is our rows, and then within the rows we get the column, so it's row then column. And get in input so map and key. What are we doing wrong? Because we're getting nil. Let's just try get in input 1 1 gives us 49. So it looks like must have something wrong here. Let's see if y, so it should be 3. If x is less than 23 and x greater than 2, let's see. Alright, so our first one should be 0 0, so that would be when x greater than 2, y is greater than 2. So x equals 3, y equals 3. So get input. What does get input 0 0 give us? It gives us 8. So when x is equal to 3 and y is equal to 3, we should be getting 0 0. Our range okay, let's do this. Let's comment that out and just see what pair we're getting. So it'd be y and x. So 4 0 is our first one. Oh, now there we go. That's probably better. Okay, so it should be 3 0 4 0 5 0. 3 0 4. Oh no, it should start with 3 3. Should start with 3 3. So inbounds x and y. That's not very good. Yeah, okay. One, 1, 1, 1, 1. All right, this is probably right now. These parentheses will get you. Okay, 1, 1, 1. Okay, there's one set of ones, another set of ones. So we have 1, 2, 3 sets of ones. And then 1, 1, 1, 8. And then at the end, it looks like we have 4. Let's see, so we need less than 24. Alright, all these off by 1 errors. Work through all this. And now let's look, we have 1, 1, 1, 1, 1, 1, 1, 1, 1, and then, oh, we are still wrong. X less than 23, y is less than 23. I think that was right. Alright. Oh, it just happened to be a 1 in the column I was looking at. 2021. Alright, because now it's... Okay, we have the rows. (2021). Alright, I have the rows and the columns mixed up. So let's go back, switch that back around. So 111, and then starts with 8, ends with 8. Alright, so now we have it right again. Okay. Good. So we now have our padded map. Padded map. Can be equal to all that. Good. Padded map. Alright, and now what we want to do is we want to define some offsets. It'll be a vector of vectors, and it'll be 0, 0, dx, dy, 0, 0, and then we'll do 1 and 1, and then 2 and 2, and say 3 and 3. So that is diagonal to the right and down. Okay, so now we can say we'll do define a function, find product. It's going to take in a map and an offset vector. I mean map in a 2D vector sense. And so basically I'm going to say what we want to do is we want to map get in and we are going to apply that to M, and we will use our offsets, and we'll do that across O. So we're going to take in our map, and then basically we're going to map this get in with our vectors across the map. So let's just test that out. We have our function find product. Let's do a find product padded map and offsets. Let's see what we get. Alright, 1, 1, 8. Okay, what do we want to do? We want to do... Okay, but now we want to run that across the entire map, right? So we're going to say for I is in, I'll call it X is in the range of 3 through 23, and Y is in the range 3 to 23, and then we want to do this, except we want to use the offsets to get into. Let's change this up a little bit. We're going to say our function that we're going to map, it's going to take in a vector with a dx and a dy, and then what we're going to do is we're going to get in our map, and then what we're going to get is we're going to get we're going to get plus x and our dx. And then we're going to get plus y and dy. So we're going to get in the map x plus dx and y plus dy. And then we will map that over the offsets. And that's the end of the function. Alright, so now let's try that out. We map. No, didn't quite get that right. We're missing parenthesis here. Good. Alright, so now here we go. So we have 8, 9, 31, 23. So that corresponds to here 8, 49, 31, 23. And then the next one 2, 99, 73, 4. Okay, good. So we're making some progress. So we have that worked out. So now what we want is the product. So we can just do reduce on multiply over that. Try that again. Okay, and that gives us all these products. So now we need the offsets. Those are diagonal one way. Let's call that diagonal 1. And then we need diagonal 2, where one goes up and one goes down, right? Right now we had right and down, and now we need right and up. So the sign will just change for one direction for our offsets. Okay, and then we can do def D3 is where we're gonna hold our x. If we hold x constant and move right, and this is gonna be say across, be zero, 0, and then we'll hold our x and we'll start moving our y. 0, 2, 0, 3. Okay, and then we need another one that is up and down. We'll just call it down, where it's the opposite. Our height is changing. Our row stays the same. Our column is changing. And 3 and 0. Okay, so then we have the two diagonal ways, and then we have left and right. And then we need, we'll define offsets as a vector of those, D1, D2, and across and down. So D1, D2, across, down. Okay, so now what we can do is we can now map find product across our offsets. Make sure we get that reduce in there. Oh, yeah, we had our reduce. What we didn't do was we want to get the biggest out of all of that. So let's do apply max to that. Okay, so now we have to redefine that, and now we'll run it across our offsets. Don't know how to make a sequence from long. Let's undo this. Find product. And let's do find product of our padded map with our diagonal D1. And that gives us that. So we should be able to say apply max. Right, I put the apply max in the wrong place because I had it nested in the for loop, so that's not a good thing. So what we need to do is we need to here apply max. Sure, that makes sense. Try that again. Find products. Now we can get rid of this apply max here and run it. And okay, so 40304286 might be right, don't know. Looks reasonable. And now we can map it across all of our offsets. And then we want to do the same thing. Apply max across that. Alright, and then we end up with 706000674. So let's give that a shot. 706000674. 18997. Hey, we got it right. So that was a little bit of a headache to get through, but got through it. So thanks for watching.